It's cool. The videos were cool.
Okay, we are live now. Screen share. What is it? Go full screen again.
Function F11.
Should be live for everyone.
Yeah. This is a lot better than a whole room full of people waiting to start.
You're trying to I love this one is test 0, fail 0.
Okay. They say they can see the slides.
Test. La 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 la. There we go. Doesn't want to get tight, does it? I was trying to point it more up toward me like that, yeah. Do that down there. Okay, there we go. Again, so many levers.
Yeah. These levers I'm used to. YouTube levers I was working on a wood project and the knife slipped up. And of course, it's just not.
If I point, will you progress the slide? Okay. Should I go ahead?
Go ahead.
Okay. We're gonna talk about Angular. So I don't know if you can really see this. Should we do lights or is this okay? As far as should we turn them down? Okay. Oh, there's only like one knob over here.
Yeah.
I'll stand back. Oh, so I'll post a link. Actually, I should get a link to these in the thing now. If you go to the get.evergreen-ils.org and look at the working/random repository, the branch on the very top, it's called ang6 notes or something like that. That's where the slides are. And I posted the HTML version, so you can just click to the HTML one. Yeah. So these aren't amazing slides or anything. This doesn't really have any structure. What I decided to do was put together a list of things that I wish had been more obvious to me when I first started working on the Angular 6 stuff, in the hopes of saving people time as they start looking at the new code. Because there's a lot of new stuff with the TypeScript, and the compilation is different, and the way the classes talk to each other is all different. So I wanted to just highlight a few things that I would have found helpful a while back. Look it up. And one more. So the components in Angular are very similar to AngularJS in the sense that you have a chunk of code that lives off to the side. You pass data to it, it does something and renders something. That part's not really different. The syntax, however, is very different, and it's more expressive. So there are more ways to pass information to a component. The first and most simplest way is if you have your own component defined and you have some attribute, you can just pass a string to it like that, just like a regular HTML attribute. It took me forever to realize you could even do that. I thought you had to do some magical brackets and wrapping and all this stuff, but no, you can just pass strings in that way. And the part on the bottom here is how the actual TypeScript would define the attribute. It's an input. This is a special decorator that Angular uses. Give it a name and then a type. The type is for TypeScript specifically. You don't have to have a type. You could call it an any type, which is basically I don't care, void star. But of course, the code is more, well, it'll give you better compiler warnings and more meaningful warnings if you give it a type that makes sense, and it makes it easier to read for people reading your code later. So I tried to be pretty strict about my TypeScript adherence. Hook it up. All right. So the next way to pass data to a component is passing a reference to a variable. This is more like what you're used to in AngularJS, where you say the attribute equals something, and that thing is a variable reference inside of your JavaScript. So to do that, we do the square brackets around the attribute, and that's saying whatever is in here is a reference to a variable, and I'm going to treat that as a way to link these two things together. And down in the component implementation code, we have the input again, same thing, not really different. The way it's defined right here, when the component is initialized, it'll pull whatever exists on this variable into some attr, and that'll be the variable, and that's it. There's another way to do it, though. They make it possible not only to pass something in when you instantiate the component, but you can have it so data flows over time to the component. So if you are working with asynchronous data and you want the component to update with more information as data arrives from the network, the component can be written in a way that it can receive this data, and that is by using something they call a setter. So again, the input, again, the sum attr is the thing I want to set. We put this keyword set here in front of it, which is a TypeScript keyword. I think it's maybe kind of a C# thing where they have setters and getters. And you define a function, and then every time the calling code value changes, this function will get called and will get passed in. So it's basically an on-change handler for the values, and then the component itself can react to that and set its own values. It can react to that and run other code and do whatever it needs to do. But this is hugely important, and it comes up a lot. And by default, if you're not sure which one to use, this one is more powerful and does everything this one does. So this one's good. It just requires a little bit more code. All right, now, yep. So then going in the opposite direction, data flowing from the component back out to the calling code. So this is event handling is basically what it is. If you have a component that does some work and it wants to tell its caller that something happened, it can then run functions to tell it that. So that's when we use the parentheses. So the parentheses basically indicate data flowing from the component out to whatever is over here. And there will always be this special variable called event. That's the thing that's passed to the function. And then typically you'll pass some type of function that gets called here when the event runs. And you use the same kind of notation for like on click and on blur and stuff like that. It's just anything that might be happening inside of here that passes data out to the caller, wrap it in these guys, and then give us some code to handle it. Inside the component code itself, you set up what are called event emitters. And this is just another style of event handling in JavaScript. And these event emitter classes come from the React.js libraries that Angular pulls in. They use it a lot, and it's kind of peppered all over the place. But the idea is that you create an emitter and you just hand it data, and it just passes data off to anyone who's subscribed to it. So they kind of reuse this as a way to attach handlers onto the attribute wrappers here. So the component creates an emitter whenever it needs to. It says emit this thing, and then the calling code will get that data here with event. And the calling code can also, if it has a reference to the component, you can subscribe directly to it by using the subscribe functionality. And then last but not least, the bidirectional data binding. This is most like what ng-model is in AngularJS. You give it a variable. If you change the value of the variable, that goes into the component. If the component changes the value of the variable, it comes back out to you. So we have, no surprise, both of the notations around the attribute. In my experience, most custom components don't implement a thing called ng model that just have variables that you pass data in and other things that send events out. But you can do that with some special trickery. I'm going to pause a second. So that's kind of the one of the things that took me it took me a long time. It just was less obvious to me, and I didn't see enough examples of it up front. And writing and talking to components is such a core part of everything you do in Angular that knowing that all the different brackets and how they behave is, I don't know, I think it's really good to get that down pretty early before you start using it. And I kind of just rattled off a bunch of stuff. Does anybody have any questions about that? All right, we'll go on then. Let's see. Okay, there's something that's more common in Angular than AngularJS and much easier to do in Angular is you can have references to components. So I want to try to think of a concrete example here. If you had a patron search component, for example, in the AngularJS code, in Angular, if you had the same thing, you could have a reference to it, very easily defined. You would basically just give it a internal identifier called my component or whatever you want to call it. And then inside of your code, you would say, I want a reference to this thing, and I'm going to access it by this magic identifier selector, basically. And then once you have a reference to it, you can call functions on it. So if you had a patron search component over here that did all this stuff, you had a reference to it over here, you could say, all right, search, or all right, do this, or all right, do that. It doesn't necessarily have to interact through the motion of pages going from one to the other. You can just talk to it and tell it to do stuff. And this is particularly handy. It's use it on, say, like dialogues. So if you want a confirmation dialogue, you can manage that all from the template, or you can pass a reference into the code, and then from the code you can say, all right, dialogue, open yourself, close yourself, make this your value, do whatever else you want to do. It doesn't have to just be markup driven. The Angular syntax is not terribly different. You know, I mean, I think you can probably tell what this is doing. You can tell the for and the ifs. That's not really all that different. It's just different decoration. Obviously, a big new one is the I18N. Any tag that's tagged with I18N will cause this string to be extracted and put into the XLFF2, whatever files that we're using for translation. So anything that has bare English text in it, you need to do that. You don't have to do anything special for the variables. Those are built into the translation framework. You just put the variables in there. Something that's used a lot more commonly is the templates, and I think containers are brand new. Templates are a way to define a template content, but you're saying don't render it now. Just hold on to that, and then we're going to do something with it later. And the most common thing, and I have another example of this later, but the most common thing is to define the template and then give a reference to it to something else, and then it does something with it. And then containers are no-op containers. They're, you know, so many times we have to do like div, ngif, blah, and then put stuff in it. Well, you're just adding an extra div, which doesn't serve any purpose. So you can use containers instead, and they'll disappear in the code that's compiled ultimately. So a slightly more concrete example of dynamic templates and template variables. I have a chunk of code that wants to invoke an advertisement banner type thing. And the advertisement component says, I don't know what you want to display. You can display whatever you want. Just tell me, give me a reference to the thing you want me to show, and I'll show it. So I start out with my template, give it an identifier, and I have to specifically say which variables I want to reference in the template. And then I put the content in there. And then at page load time, this doesn't do anything. It just sits there as a precompiled blob. And then later on, when I when I invoke my add component template, I give it a reference to this guy. And then somewhere else later on, that add component, which is running somewhere on your page, says, you know, oh, I have a reference to this template. It's time for me to render it. I'm going to render it now. And then that pops up wherever it wants to be popped up. So you can pass all these preformed things off to other things, and then they know what to do with it at runtime. Another thing that's I don't really think it exists so much on the AngularJS side are the lifecycle hooks, and there's a URL to the Angular page for it. It's kind of like Apache hooks or mod Perl hooks, child init, that kind of stuff. There's 5 or 6 of them, and ng on init is probably the most common one. It gets called after the component has all of its initial data has been passed in. So if you need to do actions that happen after the component has sort of been awoken and it exists with all of its pieces put together, then that's when you'd want to run those. But there's other ones for like on destroy. If you have certain resources that you want to release, then you can do those in on destroy, and you can watch for changes, and there's other hooks in there that come up from time to time. They have some canned event bindings. Again, we have our parentheses. So we're saying data is coming from a component out to something I'm calling. And they have these canned ones for key up and blur and all the regular HTML events. And then they put sort of like action-specific specifiers on some of them. So instead of having to check for, you know, on key up does code equal 13, then submit, that kind of stuff, you can just put those in here on various inputs, and it'll call whatever you call when the user hits enter. That's pretty handy. The module stuff is one of the more frustrating bits about it. It didn't make a lot of sense to me at first why they have all these stuff broken out into different pieces. And I still struggle with it a little bit. It's easy to duplicate things or to get things in the wrong order, and you just don't know why they're broken. So I tried to make sure the base component that's there now covers most cases, and you don't have to import a lot of new stuff. But obviously, we'll all be writing new modules and new components and everything, so we need to know how they fit in. So mainly what they're there for is pulling in dependencies, exporting dependencies, defining routes, and yeah, that's pretty much it. All right, so there's, when you define a module, it's 4 kind of parts that are used. You don't have to use all 4 of them. The declarations are components. So again, if we had the patron search component, somewhere someone has to say, I declare this thing works, and this is how you find it. That declaration can only exist once in the entire application. So if you have a component that doesn't live in a module somewhere, it's just a random floating component, it needs to be declared somewhere that's shared by other components at all, or other code that wants to use it. If you have module A declares the component, and then module B over here declares that at runtime you'll get an error, so you have to move it down to a lower point where they can both import it from a pre-declared module. The imports, just pulling in other modules that are needed for this code. Exports, anything that is in there is automatically available to anyone that imports the current module. And then if you scroll down, if you can scroll down, yeah. Providers are lists of services. This one is really, I mean, it's just an import is all it is. I don't really know why they break this out to a separate thing, but it's there's got to be some reason for it. But anyway, this is where services go. And you can also define services, and by services I mean things like the IDL parser and authentication and all the low-level stuff. You can also tell them that they're universally available and they don't have to be imported in here at all. So none of the core services are even listed in these providers things in the modules. The routes, the path definitions are consistent with AngularJS as far as like how the actual path layout goes with the colon parameters. And so that's not really all that new. You can put other parts in the route, like you can put static variables in there and stuff you can reference later, but this is a pretty standard routing setup. So this is a catalog, the kind of catalog thing that I put together. So, you know, it has a record page and an ID and then a sub tab. And then if you go to the next slide, you can see it pulling that data off from the route. Angular has a service called activated route. And so you have a reference to that, put it in the constructor. And then it has a parameter map event emitter thing I was talking about earlier. And you subscribe to that. Someone navigates to a new tab in the page, this thing fires. And from here, we can check to see if the record ID changed or if just the tab that is selected changed, and then run whatever actions you want. Lazy loading. Just recapping this real quick. I think I talked about this a lot in my last Angular thing I did. Most of the application is lazy loaded. There's a core component that is just the, you know, like the auth token stuff, the IDL parsing, the event handling stuff that gets loaded on by everything by default. And then everything else is loaded, lazy loaded, depending on what path the browser goes to. So when you navigate to, can you scroll down just a little bit to get rid of that screen sharing thing? Okay, that's good enough. So this is just an example of navigating to a catalog record page. Every browser loads these first things: the base module, the base routing module, the base resolver. That's just very minimal stuff. And then the browser says, give me the code for the staff module. And then it loads the code for the staff module, and then it loads the routing module, which is this guy. And then the routing module says, hey, if you go to the catalog, don't do it now, but when you go there, grab this code. So then that code gets grabbed, and then we parse the catalog module code, and then we load its routing code, and then if it has a resolver. The resolvers here are the same as AngularJS resolvers. They run before the page starts. And if the resolver fails to load, then the page will not load. All right, almost done here. I know this is kind of just a wall of information. Observables are hugely important. They come up a lot. So this is in relatively recently, promises were implemented in most of the major browsers, certainly in Chrome and Firefox. They are not as expressive as promises in AngularJS, which were something that someone coded. And the $Q promises in AngularJS support on complete, on notify, and on error. But the browser versions of promises don't do that. They only do on complete and on error. So that's why observables are a big part of this, so that we do streaming data. So the network code in Angular 6 uses observables so that it can stream values back. And it just comes up over and over and over for managing any kind of data flow. And there's a huge wide array of API for the observables. A link to the documentation up here. And you can, so anything you can imagine doing with a stream of information, you can do with this stuff. So they have piping and mapping and all just, yeah, there's hundreds of functions you can call in there. One thing that's annoying to look out for is in your working on an Angular 6 component, or a page rather, if you write some code that breaks it enough that the router can't properly resolve, then it'll take you back to the home page. So that's annoying. It just takes a little getting used to, because you're used to write some code, refresh the page. Oh, there's an error. I'll go fix the error, refresh the page. But if the error is so bad and early enough in the build or in the rendering step, you'll write some code, fix the error, hit refresh. It'll take you back to the home page. And then you have to navigate back to the page you were on and then kind of fix it from there. So just if that happens, don't be surprised by it. We were talking about this earlier. There's a much greater weight on keeping the packages tiny, especially for the production builds in Angular. So one thing I just want to do a reminder, if you are adding a dependency to the Angular stuff, and the dependency is only used for compilation or testing or some other part that the browser doesn't care about, then if you use save dev, the browser will never have to see that JavaScript. It won't be bundled in the final thing. By default, they bundle it in the final thing, but TypeScript, the browser doesn't know what TypeScript is. It couldn't make any sense of it, so it's just a development dependency. And then recapping the compiler stuff, when you're working in development mode, using the JIT compiler, which is kind of the default, is faster. So it's typically that's what people do. And it has a watch mode, so you can make a change and it'll just recompile that one little piece. But this also sets up a higher bar for the browser. It sends the JIT compiler sends the Angular compiler to the browser and a bunch of other symbols and stuff that the compiler needs to use to build the page. So it's sending a whole bunch more stuff to the browser, but it happens to make development faster because it compiles faster. So that's kind of the default. But production mode is how we, of course, want to use it when we're using it. And I often recompile in production mode just to make sure I didn't break something. And it ships out a whole lot less code when you do that. So that'll be the goal overall, to use the --prod flag. And when you do that, it'll create a bundle of files. All the files will have hashes of file names to get past the browser caching. So the file names won't make any sense. It'll be a bunch of numbers.js. But that allows us to do the cache busting stuff. And then I mentioned this just because if it's helpful to anyone else doing development. When I'm doing the EG2 stuff, I just set up a symlink to the directory. And then if I have ng build watch running in a separate terminal, edit over here, and then in the corner of my eye, I see ng build watch compiling it, and that takes, half second or whatever, and then I can immediately refresh the browser, and I don't have to copy any files around with the symlink. There's also an ng lint tool, which is, I don't know how much we want to try to enforce this or whatnot. Most of it is a style guide. It's like, well, you got to put brackets on your ifs, even if it's just one line, or you missed a semicolon here, even though it's not really required. I think it's helpful. I try to use it. But it also does other things like if you accidentally import a huge library, like the entire RxJS library, and that's pulling in megabytes of stuff that the browser's going to have to download, this thing will warn you about stuff like that too. So it can help you tighten up the download size. And there is also a Vim syntax highlighter for TypeScript. There's a couple of them. This is the one I've used that works pretty well. So, oh, I thought I had a new thing on the end there. No, it's fine. It's fine. So the big, I don't know how to put this. There was a huge emphasis on security on the Angular 6 stuff, and part of it had to do with not sending the Angular compiler out to the browser. And part of that is that it can't execute Angular code that it doesn't know about before, or that it doesn't know about after compile time. Let me rephrase that. You know how when you go in the receipt template editor, an AngularJS client, and you go in there and you write a bunch of HTML and add a bunch of stuff? That won't work in Angular because that template wasn't precompiled. So it won't know how to parse it. It doesn't have an Angular parser. It's just running precompiled stuff at runtime. So with Angular, we lose the ability to just give it a random bit of HTML and have it execute the HTML. So kind of the big question right now is, how do we manage custom receipts? Just to throw some things out there, there's, make the custom receipts much more configurable than they are. Right now, they're not configurable at all. We assume you're just going to edit them. So we could give them a lot more bells and whistles. There's server-side printing. That's what we do on the self-check, is a server-side template that generates the receipt. There's, let's see. Yeah, you could have templates that live on the database. So you edit it in the interface, it goes to the database, and then it goes through the compiler stage, and then it goes back out to the client. But that assumes that people have the Angular build environment in their system. And then the other kind of part of that is the whole, I want my library's templates to look different than my other library's templates. We don't have that without Template Toolkit. So that's something else we need to consider addressing fairly soon. So yeah, that was these were all notes I was taking as I was writing code. So it's kind of chaotic, and I don't know really how helpful that is, but hopefully I can at least use these slides as a little bit of a reference at some point. Before Galen comes up, does anybody have any questions about any of the spew? No. All right. Well, I'm around if anybody has any. And I think you don't have any slides, right? We don't need to do anything up.
Okay, so for the benefit of the people on watching the YouTube stream, I'm Galen Charlton with Equinox, and just very briefly, I'm going to talk a bit about some work we've done to figure out what additional base components we may need to add to the Angular staff client.
Ignore me.
So the context for this is a project that Equinox is working on to rewrite the acquisitions staff interface from the Dusty or the Dojo framework to Angular. So in the course of looking at the stuff that Bill had put together, if you go through it, you'll notice that there are already a bunch of user interface components available. E.g., a ComboBox being one of them, where you can define a static or dynamically generated list of values, and have an input widget that lets you select a value and also implements type ahead. One of the things that we identified is it would be a niceness to teach that about a field mapper. So to make a subclass of, e.g., a ComboBox, toss it an IDL class and some information about what value or what column you want to display in the dropdown, what value you want to bind on, and have it automatically take care of retrieving, issuing the necessary peak read calls without everybody having to write tons of boilerplate code to fetch values. Another one we've identified is going to be really simple, is a popover. So cases where in the prediction pattern wizard in the AngularJS stuff interface, you'll see some of these where you can click on a question mark and find out, oh, what the heck is a regularity or whatever. So we'll be writing a similar widget for the AngularJS side. I think one of the open questions, and I think will involve dig, is with the new staff client, we potentially have an opportunity now to say, do we want to start putting in hooks for deeper linking between the staff client and the portions of the Evergreen manual that describe it? So the popover might be part of it, but I think that's something well worth discussing sooner rather than later, because I have ideas of, okay, automatically or mostly automatically maintaining links between an interface and a manual, but also we could look into doing things like making it easy for somebody to write customized documentation for their particular Evergreen instance. So I'm just tossing that out as a potential discussion topic. Another area we'll be working on is giving EG-Grid, teaching it how to readily filter rows based on conditions you set on one or more columns. If you look at acquisitions or some of the other Dojo interfaces, many of the grids have a button that you can click to filter, and that button pops up a dialog box saying that, okay, I want to filter, say, on all orders that were created after date X or whatever, and it lets you choose your columns, it lets you choose your criteria, and then filter the results of the grid. Well, we're going to be doing that same thing for acquisitions. And there we actually have, a question, in part, directed at MassLink, who's funding this, whether to present this as a dialog box giving you the ability to choose your filters and or choose your adventure, depending on how deeply invested you are in the interface, or to display the filter widgets more in line in the grid, by which I mean, if you have a grid, you have your column headings. Below each column heading, you could have an input widget saying, this is the value I want to filter on. That's, but regardless of how it's presented, that's one of the things that will be coming, is the ability to filter grids. And it's been particularly, the Dojo equivalent has been particularly useful in acquisitions, but I could see other areas in Circ and also particularly holdings maintenance where that could be handy for folks. And we'll also have be doing a bit of a back-end work to wrap a broadcast channel and a nice little package so that when you're dealing with multiple windows that are related to each other, you can nicely arrange for. So that's kind of a preview of some things we'll be writing specifically for the acquisitions project. But I know that Bill's also, I think, completed or mostly kind of completed a rewrite of Vandelay.
Completed minus the ACK.
Okay. So another thing I want to mention for folks starting out and looking at this great big pile of good stuff that Bill has given us is there's a Sandbox page, that you can, where most of the components are demonstrated, and it just gives you a place to go if you want to experiment with stuff without necessarily writing entire components from scratch right away. So that's kind of what I have. Are there any questions either for me or for Bill?
Somebody in the channel.
I'm asking for the.
Once, I guess I do have a question. So this use of components means we're going to have a less duplicated code than we do now. So I recently did something with marking item discard read, and I've noticed that in a lot of places, the code that was existing there to mark items damaged or mark items missing, for instance, it goes through and calls this existing code that exists on like the search service, but it goes through the item service to get there in most places. And then in various places, it's doing almost the exact same thing to call that code. Would components help us with not having to repeat that code, because we'd have like a component that would do the mark? Like if we made the mark code kind of a component or a service, we would then just use that directly on the other pages instead of going through all these other multiple layers along the way.
The idea of a component in Angular is very similar to the idea of a component in JS. And it's not the same thing as web components, although there's a lot of similarity between the two.
Got that far.
Okay. So if there are cases in the Angular JS code where we're repeating ourselves, that's just our fault. It's not a fault of the tool. It's just code that probably needs to be refactored. Yeah. I mean, so the two different things, the two or three different things that are calling the same stuff could be refactored to call it once.
Well, in a number of those places too, in all fairness, the code's not identical. There's differences in some of those areas where it's before the code goes through the marking system, it's got to be the object has to be flattened into a hash. In some places we have the hash already, in other places we don't. So part of that is it's like flattening them into loops and stuff like that.
Right.
Thought I had another one about Lambdas, but I'm pretty sure the answer is going to be yes. Because it was in some of your slides. You used it basically that new Lambda syntax in JavaScript.
Yeah, I didn't even think about that. I use it without thinking about it now. But I'm using it in the context of TypeScript, and I realize that a lot of that is already moved over to JavaScript too. But
Do you know if it files down to the non-arrow function?
I think it compiles down to the old school function types, probably for a long time, I would imagine. Something like that.
Mm-hmm.
We don't support Edge. What do we care?
Yeah. Somebody in IRC asked if you have any tips about debugging.
The Angular 6 stuff.
Yeah.
The process is, can they hear me? Or they're on IRC, or on the thing.
The sound monitor seems to sense of it.
Okay. The really, it's pretty much the same as Angular JS. I'm trying to think of the key differences. The compiler helps a lot. When you're writing the TypeScript stuff, most of the errors are resolved on the compiler because it tells you all the dumb stuff you did when you were writing the code. So you have much fewer runtime errors. And of course, when you do that, it usually boils down to checking the JavaScript console and adding debug logs and all that kind of stuff. The errors are different. So when you first start doing this, it'll be frustratingly annoying that the errors don't make any sense because it's just a whole new batch of things that are, links and 50 pages long of errors. But fortunately, you don't have nearly as many of them with the compiler checking. So I would say write the strictest TypeScript code possible so to let the compiler do all the work for you. And other than that, it's just regular JS debugging.
Another question from IRC. How much have y'all been using the ng generate command in the Angular 6 CLI? More broadly, what's the best way to get started with a new module or component?
I gave up. I didn't give up on it. Once the structure exceeded their very simple boilerplate setup, I stopped using the ng add and ng generate and all those tools. The simplest way to do it now is just create a HTML file, your TS file, and then go to work on it, and then add it to whatever module it needs to live in. I don't use the ng generate tools. We could. We'd have to configure them, and we'd have to have a lot of switches and flags to where it puts all the files and everything. But after initially figuring out how it all worked, it didn't really serve a lot of purpose for me.
Anyone else? Thank you, Bill and Galen.
Thanks for the look at, Rogan.